All right, so hello, Guildford. Nice to see you. Thank you so much for coming on a sunny day. I can't believe you're all inside learning about science. This is wonderful. So my name's Melanie Bailey. I'm a professor of analytical chemistry, but I'm actually a physicist. My first degree was in physics, my PhD is in electronics, and now I'm a chemist, kind of doing forensics and biology. So I'm basically trying to hit all the sciences. So I'm here to tell you about measuring stuff and why it should be important to you, why it's interesting, and why it's important to society. So the way that we measure stuff is we weigh molecules, and we do this using an instrument called a mass spectrometer. Has anybody heard of a mass spectrometer? Yeah, Oscar, I think you probably have, haven't you? My son is here, Oscar, and he hears a little bit too much about mass spectrometers, don't you? So a mass spectrometer is an instrument that can weigh molecules very, very precisely. And in fact, some of the ones that we have here at the university are so precise that it's equivalent to, imagine that you've got a jumbo jet and somebody offloads a biro from that jumbo jet. We can detect the difference in mass from that jumbo jet before and after you offloaded the biro. So that's the sort of differences in weight or mass that we can measure. And what we can also do to identify a molecule is we can smash it up into little pieces, and we can weigh the little pieces in our mass spectrometer. And so we can tell how much of a molecule we have as well as what it is. Now, mass spectrometers can cost all sorts of values of money. They can be handheld, they can go in a car. I've got a collaborator in Florida who drives around in his car. It's got a mass spec which actually sniffs out clandestine drug labs. He's also got one that goes in his backpack that he took to Antarctica to measure the air quality in Antarctica. And there's one that actually went up to Mars as well. So they can be very small and very rugged, and cost as little as £10,000, or you can get very high-end laboratory mass specs, which can cost as much as £3 million, which is the sort of mass specs that I'm going to be talking about in this talk. So one of the things that we do in our lab is we use mass spectrometry as an imaging tool. So we can make images of molecules in samples so we can see exactly where they are. And biologists have been using these for many years to image drugs in tissue, for example, so they can see whether the drug has actually got to its target. So, for example, if you've got an antibiotic and you're trying to reach some bacteria, you could use mass spectrometry imaging to see where the bacteria is and also to see where the drug is, to see if the drug has been effectively delivered to where the bacteria is. Now, one of the things that we've been doing more recently, I guess, is working with the police using mass spectrometers. So I've got a PhD student who is a part-time fingerprint expert at Thames Valley Police. And then she spends the rest of her time working in my lab. And she used mass spectrometry imaging to make images of fingerprints that have been left at crime scenes. Because one of the things that we found is that you can use imaging mass spectrometry to develop more fingerprints than the police can. It's actually really effective. So a fingerprint, do you know what a fingerprint is made of? Does anybody know what's in a fingerprint? Oil, yeah, correct, good, well done, 10 out of 10. Anything else? Ink. Well, I guess if you touch some ink, yeah, it can be. My fingerprints get quite inky sometimes. But a natural fingerprint that somebody has secreted is sweat. So the sweat that comes out of your fingers is actually quite watery. And so that consists of amino acids, urea, water, drugs that you've taken or touched, things that you've touched. And if you touch your face, and people touch their faces quite a lot, don't they, in the hair, then you can get oils in your fingerprint. And so with mass spectrometry, what we can do is we can make images of all those different molecules. And the chances are that one of them will be present in a fingerprint, and therefore we can make much clearer images than the police can. And so that technique has actually become so successful that the police have started to adopt it and use it, and it's recommended in the Fingerprint Visualization Manual, which is the manual that the police use for development all across the world. So it's sort of the recommended processes. So one of the other things that we have actually done through this, so through the work that we did with the police, with the fingerprints, we were approached by a company that were trying to develop a drug test. And we helped them to develop a drug test based on a fingerprint. So if you think about it, when you take a drug, it's metabolized, it's absorbed, it's metabolized, and then it's eventually excreted. And you excrete drugs through urine or through your breath, but you can also excrete them through sweat. And so you can see the drugs that people have taken through their fingerprint. Not only do you see the drug, but you can also see the breakdown product of the drug. So the molecule is actually broken down in your body, and that can be excreted through your sweat. And so we can actually see that drug metabolite within somebody's fingerprint, and that can tell you that somebody has taken an illicit substance. Any idea why we might use fingerprints to test for drugs? Anybody got any ideas? Yes, exactly, yes. Yeah, because you actually have... Yes, exactly. So you've got the identity of the person, haven't you? Embedded in that sample, you've got the ridges as well as the drug. So you know who gave you the sample, you've got the chain of custody. It's very difficult to actually falsify a fingerprint. So that test is now commercially available. It's used by Next delivery drivers, and they have the HS2 contract as well. So it's a really exciting opportunity, because testing for drugs is conventionally done by urine, which is very easy to falsify because it has to be done in privacy. Now, if you think about it, there are all sorts of places in medicine where it's necessary to test for drugs as well. So we've been working with different hospitals to look at testing for antibiotics, antipsychotics, anti-epileptic drugs, which have to be sort of monitored at a very sort of set level to see if we can use a fingerprint as a really non-invasive way of testing people in hospitals. And so far that's looking quite good. We can see all the substances that we're interested in. The real challenge is trying to actually get a quantitative measure of how much drug is in somebody's fingerprint and how that relates to the level in their blood, which is what the clinicians really need. So going on from that, we spent a lot of time in hospitals prior to COVID doing this, and then the pandemic came, and probably about a month before the pandemic we got kicked out, and we couldn't go anywhere near any patients in hospitals, so we really had to sort of rethink what we were doing. All our work sort of fell away, and we decided to sort of repurpose what we were doing to see if we could help with the pandemic. So we joined forces with scientists from lots of universities, Manchester, Liverpool, Oxford, and we formed a collaboration, and together we went out to collect samples from COVID patients in hospitals, which was certainly an interesting experience. And we collected blood, we collected sebum, which is a swab from the back of the neck, and we collected saliva from these patients. And we used mass spectrometry to measure them. And we found all sorts of interesting things. Firstly, we found that your saliva can convey how ill you are going to be with COVID, which is interesting. And so we weren't quite fast enough, unfortunately, to implement this test in hospitals. But in the future, perhaps you could use a saliva sample in hospital to triage patients. Do you remember when A&E had hundreds and hundreds of patients? They were so busy and they didn't know which patients needed to be sent to intensive care and which patients could go home. But if you could have a test that could tell you how ill a patient was likely to become, that could be really valuable in future pandemics. Something that we also found, and I probably shouldn't admit to this, but I'm going to admit to it anyway and hope that nobody really listens, is my family got quite ill with COVID at the start of the pandemic because my husband works in a hospital and he brought it home. And we tested our sebum. So we did the Bailey family versus the rest of the lab. And we found that there was quite a big difference between our sebum and the sebum. So this is the oils from the back of the neck, right? And we ran it through the mass spectrometer. And the molecules in our sebum was different to the molecules of the rest of the lab. And we thought, oh, well, it's just a different washing powder, maybe the Baileys eat a different diet. There was some speculation about the Baileys being fitness fanatics and the rest of the lab being couch potatoes and all that kind of thing. And anyway, we went into hospital and we tested the sebum of COVID patients, and we found that it was completely different. So if you've got COVID, your sebum has a completely different composition to patients, even patients with other respiratory conditions. And so this could be a way of testing for infectious diseases in the future. So I hope I've been able to tell you some of the really exciting things that mass spectrometry can do. Something that we're just setting up at the moment, just to give you an idea of how sensitive these techniques are, is we're setting up a facility that's going to enable the analysis of single cells. Okay, so we can pick up one cell into a capillary and then spray that cell into a mass spectrometer. And that's going to be really important for understanding all sorts of things like infectious diseases, how they work, medical new treatments, whether drugs are working when they target cells, whether they reach their target. And so that's our work for the future. So I've noticed that I've completely run out of time. I'm sorry for talking for too long. Thank you so much for listening. And if anyone has any questions, I think you can come and find me by the bouncy castle with Oscar, right? Okay, thanks very much.